Question 28. So, if you look at this graph, we've got the length of the call in minutes. So that's the length of the telephone call. And going up the side here on the y-axis, we've got the cost of the call. Now, what you'll see is that it doesn't start at 0, 0. It starts at 0.5 pounds, or if you like, 0.50p. So what we're saying is, even if your call length is 0 minutes, it's still costing you 50p. Now that's what's called a fixed charge. It's the extra amount you pay for a call, regardless of the length of the call. So give an interpretation of the intercept of the graph on the y-axis. Well, this 0.5 pounds, or 50p if you like, is the fixed charge. Now, AII, give an interpretation of the gradient of the graph. Now remember, the gradient is the slope. To measure the slope, you take a triangle, and then you divide the amount up by the amount across, and that is going to and that's the way you work out the gradient. Now, what this gradient represents is the cost of per minute. So take this triangle that I've done here. The y step, the amount up, is going from 2 to 5 is £3. So we're saying we're paying an extra £3 for every 2 minutes of call, because we're going from 1 to 3. So it's £3 for every 2 minutes of call. So in other words, it's £1.50p per minute. So how much do these calls cost? Well, they cost 50p fixed charge, and then a further £1.50p per minute. Now, this bit per minute is called the variable charge. It is the cost in pounds per minute in addition to the fixed charge. Now, for part B, as I was saying earlier on, the gradient, the slope, we work out by being the y step, the amount up, divided by the x step, the amount across. 3 divided by 2 is 1.5. And that's what I was talking about up here, £1.50 per minute. Now the c is the intercept on the y-axis, and that's our 0.5 fixed charge. So find the equation of the straight line in the form y equals mx plus c, y equals m, the gradient, that's 1.5, times x plus c, the y-intercept, 0.5. And again, it's important, I think, it's useful if you understand what we're saying here. So what we're saying is, if you had, say, a 10-minute phone call, you do 10 lots of £1.50, which would be £15, then you'd have to pay that extra 50p. So it would be £15, 50p for a 10-minute call. Question 29. Work out the gradient of the straight line graph. Well, the gradient is the y step over the x step, the amount up divided by the amount across. Well, the height of this triangle, if we take the maximum triangle available, is 68. The base of the triangle is 50, so 68 divided is 1.36. So what we're saying is we can go 68 kilometers in 50 minutes. 68 kilometers per 50 minutes, so that is a speed. It is 1.36 kilometers per minute. Question 30. So work out the gradient of the line for train A. Well, again, that's the higher one. So it's the y step over the x step. So taking the maximum triangle here, I've got a height of 60. So the height on the end is 60 up. So a height of 60, a base of 30. 60 divided by 30 is 2. B, which train is travelling at the greatest speed? You must explain your answer. So the greatest speed will be the one with the greatest gradient, which is the highest slope. So that's train A. Now, part C, after how many minutes has train A gone 10 miles further than train B? Well, looking at these little baby squares, each baby square represents 2 miles. So we're looking for where the distance is a 5 square gap between the two trains. So looking for this vertical gap between the two. And I can see when I get down here, I've got 5 baby squares difference between train A and train B. The distance travelled in miles at that point is 20 and 30. Train A has gone 10 miles further than train B. after 15 minutes. So question 31, we've got to work out the angle x. So picture yourself at the angle, that side is opposite me, that is the hypotenuse, that is the diagonal opposite the right angle, and this is the adjacent side to me, the side next to me. Now the two sides that I know are the 5 and the 14, are the O and the H. So on this occasion I'm using the sin ratio. You remember, you've got to learn your SOHCAHTOA. So sin ratio is the one I'm going to be using because this particular question involves O and H. So sin x, remember it's always the angle after your choice of ratio. So sin x equals your opposite side, which is 5, divided by your hypotenuse, which is 14. Now, to undo a sin, I inverse sin each side. So x equals inverse sin 5 over 14. Pop that into my calculator, I get 20.92 ... which to one decimal place is 20.9. Going back to this inverse sin business, if you would prefer not to just think about it as rearranging an equation, what do you need to do to make x the subject, you can just learn that when you're working out the angle, then it's always the inverse function, so inverse sin, inverse cos, or inverse tan. So it's up to you. Question 32. So picture yourself at the angle. So on this occasion the 1.9 is opposite me and the 3.2 is adjacent to me. Opposite and adjacent. So on this occasion I'm going to be using the tan ratio. So tan x equals my opposite side of 1.9 divided by my adjacent side of 3.2. Inverse tanning both sides, I get x equaling inverse tan of 1.9 over 3.2. Popping that into my calculator, I get 30.6997 ... which to one decimal place is 30.7. Question 33. So for part A, I've got to work out the size of the angle ABC, so that's what I'm just calling x here. Now on this occasion I know the adjacent side of 7 and the hypotenuse of 11. Adjacent and hypotenuse, so this is a cosine question. So cosine the angle, cosine x equals 7 over 11. Inverse cosine both sides, I get x equaling inverse cos 7 over 11. Popping that into my calculator, I get x being 50.478 ... which is 50.5 to one decimal place. Now, for part B, the length of the side AB is reduced by 1 centimetre. Now, I've popped this in red on the diagram up here. So AB is no longer 11, it is now 10. Okay, but we're told that BC is still 7, and this is still a right angle here. So just think about this triangle here with the red hypotenuse. Now, we are being asked, you've got to be very careful here, will the value of cos ABC or cos x increase or decrease? Now, cos x is simply the adjacent divided by the hypotenuse. Simple as that. Cos x, cos ABC is the adjacent divided by hypotenuse. Now, originally that was 7 divided by 11. But now it's going to be 7 divided by 10. Now, 7/10 is bigger than 7/11. So cos ABC, cos x, has increased. Now just be careful, the question doesn't ask us has the angle ABC increased, because the actual angle itself has decreased. But that's not what we're being asked. We're being asked has the value of cos the angle increased or decreased.